Okay, if you have not ever heard of the law of cosines, that will be our topic today. And law of cosines will be the first time we have worked not on a unit circle and not on a right triangle with our trig functions. So you can see two goals today. We want to solve real-world problems using the law of cosines, and then we want to find the missing parts of a triangle using the law of cosines. Now, one piece of information that's going to be important from geometry is that if we solve these different combinations, we need minimally to be given, as you can see, we need two sides and one included angle. Two sides and one included angle would mean we need side angle side or side 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 from geometry, a relationship. So look at the triangle that I have here, triangle ABC. You don't see anything marked, so we don't know if it's a right triangle. The angles really do not appear to be right, and you can't assume that any of them are. But if you look at this, there is a relationship. They give you three relationships, actually, and they all are based on a different angle. So let's focus on that. Let's go from angle C, which is the first one. And so you can see, if we're only given one angle, that C is right there. That's the capital C. Then we have the edges. We have little c, notice, which is the side opposite the angle, sticking up at the front. So I like to say our angle and the side opposite it are at extremes of each other in the formula. That's one way you can help test yourself to see if you have it set up accurately. Then it goes like this. Your other two edges, and it really doesn't matter the order. So one of our other edges squared plus the other edge squared minus 2 times A times B, those same two edges, times the cosine of C. That's why it's called the law of cosines. The only thing in it is one little cosine right there. Okay, you can do this with non-right triangles, right angles as well, so you'd be able to use your calculator, help functions, etc. So notice, and let me just reset, and let's do it with a different color. If I want to say angle B is my reference angle, then notice angle B is at the end down here, and side opposite it is little b, it's at the extreme. And then those two other edges, A and C, are what make up the math that goes in between. And notice it looks like Pythagorean theorem, a squared plus b squared equals c squared, but it depends on what letter you put in there. So we've got a squared plus c squared in this one, and then minus 2ac, single versions of those letters, times the cosine of b. So be careful because we could have, as we say, all three edges, and when I say all three edges, so in this last one that I didn't mark up, if I was giving you A, B, and C, we'd have all those parts. The only thing that would be missing would be capital A. We could solve that. So we could have all three edges given and solve this thing, or we could have, like in the first one, two small edges, the angle, and have to solve for little c. And we're going to do that in our example for this. Let's make it real world so it makes a little more sense to us all. Points T and S are endpoints of the tunnel to be built through a mountain. From a point Q away from the mountain, it is possible for a surveyor to see both T and S. He finds QS, the distance QS, to be 720. He finds QT to be 510. And then he finds angle SQT to equal 84.5 degrees. Find the length of the tunnel to the nearest meter. Well, obviously you can't just go and measure the tunnel because it's not there. So it's going to be built through the tunnel. We have to be able to use different instruments, surveying tools, etc., compass, measurements, to be able to help us do this. Now, there's your mountain. Where is your picture? In your brain, you've got to have an idea. So taking that information, draw a quick sketch, label it well, because that'll be a big, important part and piece of this. And so now we have, hopefully, a picture that looks something like this. So there was the mountain. Here, TS is that tunnel that we're going to be making, but we can't measure it because there's solid rock right now. at a point out here at Q, we, the surveyors, measured, and we have an 84.5 degree angle, with the point QS to this side of the mountain being 720, and the point distance QT being 510 on that side. And it probably should be switched around in all actuality, but we never said the picture was drawn to scale. So now if you look at that, we have a relationship of side, angle, side. And that's exactly what our problem said we needed. Since we're angle Q, we're going to call this little guy that we don't know little q. And we're going to set up the law of cosines to solve this. So q squared is equal to the other two edges. It doesn't matter what order, just take them one at a time. So 720 squared plus 510 squared minus 2 times 720 times 510 times the cosine of q, which we know is 84.5. So if you look very carefully, that whole entire right side of our equation is numbers. And you could plug that into your calculator, be very careful, and that would give us our q squared, which is not what we're solving for. We're obviously solving for q. So we would get a number, and then we would have to take the square root of both sides. So if you do this, and I want you to test your skills about entering on your calculator, so take your 720 squared plus your 510 squared, subtract 2 times 720 minus times 510 times the cosine of 84.5. Get that put in to your calculator. See what you get when you do. We will divulge our answer momentarily. Remember, putting it into your calculator, that is only giving us q squared. So do not forget, after you get that number, to take the square root of both sides. And when you do, we are finding out that our mountain should be about 841 meters. And I'm sure that is definitely rounded to the nearest whole number. I don't remember if that's what our directions said, but that is definitely it. So our tunnel should be approximately 841 meters. If you have any issues with how you put it in the calculator, please ask. The only other thing I can say right now, if you got a wrong value, is please check that on your calculator, under the mode situation, you made sure, because you put something in angles, degrees, that your mode is in degrees. And if it's not, it needs to be. So then recalculate and see what it equals. Hopefully you got the 84.1. Okay, so that first example was a side angle side situation. That's one you have to remember. Definitely want to memorize it for this. And now our second example will just be a normal triangle. So if it says, find the measure of the smallest angle in this triangle with sides 8, 10, and 12, my first question is, well, where do things go? You should know based on your work from geometry. Yes. So with our work from geometry, you should know. Again, it's not a right triangle, so you're not going to be able to use Pythagorean theorem or anything like that. But what we do know is that different edges come from different angles. So if we look here and we look at 12 being the biggest edge, then we know it has to come or be drawn out from the biggest angle. So in this case right now, there's our biggest angle, so therefore that edge has to be 12. And some of you just look at the edges. Well, that means then this has to be the 10 and the smallest one has to be 8. That's fine. Okay? But you have to be realistic in where things are at. So now the other thing we didn't do is name it. So let's go this time A, B, and C. Make it easy. All right, so they said find the measure of the smallest angle in the triangle. So based on that, what are we solving for? Smallest angle would have to be, good job, C. So let's set up the law of cosines, because why? We have a side, side, side relationship, angles missing, and see what happens. All right, to do this one, We have to set it up similarly, but it's the angle we don't know, so be very careful. The angle and the side opposite it, I have to be at extremes. So we're going to start off our equation with 8 squared has to equal the 12 squared plus the 10 squared minus 2 times 12 times 10 times the cosine of our angle C, which we don't know right now. So we will be solving for C. But obviously look at this one. It's not going to be as easy because all the numbers, ooh, there's our variable. That's what's missing. That's going to be a problem. So let's move some things out of the way so we can try to get this C by itself eventually. So here we go. Be careful. We got to undo addition and subtraction first. So we're going to have an 8 squared, and I'm not going to do the math on the numbers yet. I'm just going to move things. Minus the 12 squared minus the 10 squared. And if we did that on this side also, they should cancel. Okay? So if they do cancel, then that means all we're going to have left is that negative, and you can't get rid of that sign, so a minus 2 times 12 times 10 times the cosine of C. Now if the numbers are small, like those ones are, you might want to do the math, which is fine. So if we do, 2 times 12 is 24, and it's negative. And then 24 times 10, negative, we should get a negative 240. We could divide both sides by that negative 240. And that's all that's left over there right now is multiplication, so we divide, and all we're going to have left is that cosine of C. Okay, let's give ourselves a little more room here. So the cosine of C equals this combination, which you could put into your calculator, find one number for if you want. But what you have to remember from earlier, if I want to get C by itself, how do I get rid of cosine? Yeah, I heard it. Somebody says, well, you got to use the inverse. And the inverse looks like that. So if I use the inverse on this side to cancel, I'm going to have to do the inverse over here as well. And that fraction that I had, 8 squared, 12 squared, minus 10 squared, divided by that negative 240 is what's going to have to go in that fraction. Now be very careful, because more than likely when you go to your calculator and you punch this combination in, you're going to need an extra set of parentheses here to make sure that that numerator gets done by itself, and then this will give us our approximate C in degrees. Okay, so punch that in, and we'll see what you get for your answer. See what kind of answer we got. See if we agree. You might not be there yet, but let's check. I've got the measure of angle C coming out to be approximately 41 degrees. Now, it is probably rounded, but to the nearest whole number, but that's what you should be getting. And it just depends on how you marked your triangle, but ours was marked as little c was opposite the 8. So maybe you marked it differently, and you might have angle B there, angle A, but it has to be across from the 8, has to be the 41. So then, once you have that angle, you could use side angle side, and maybe find another combination of an angle, because you need one more angle before you can be finished. So you could do side of 8, angle of B, side of 10, and set it up that way and find angle B next. We could do that. Once you had 2 of the angles, then all you have to do is add them up, subtract that from 180, and you'd have the third angle. Okay? So hopefully, again, if you had any issues with the calculating of the angles, degrees, please let me know, because I think all we have left now is our homework. So please check with me in class if you have any issues with your calculator or keying it in and getting these correct values.